All right, young programmers, we are going to program the Blockly Turtle graphics to actually do some polar graphing. Are you ready? You're going to go to this URL up here at the top. I have a link on my webpage, and when you get here, you have a simple program that's going to move forward by 100 pixels right now. If you run the program, that's what happens. Not so much so far, but here we go. The first thing I like to do is to look at the turtle. I like to set the width for the pen to be something something just a little larger, like 2. Okay, so that when you run your program, you get a little darker line and things are going to look a little nicer. What we also need to do, you can drag these blocks away from each other, and we want to have the turtle start in the positive x-axis. And we're going to do that by turning right. So we're going to turn right by 90. And we're going to take that block out there, and poof. That's our first. That would be, if R is 100, we're going to come out 100 pixels with a theta of 0. So, as I just mentioned, R and theta, we don't have those in our diagram here. So we're going to need to put those in, and those are going to be variables. So right now we don't have R and theta here, but we can choose this set item here, and we can actually rename a variable to whatever we want. So we're going to create a variable called R and set it to, well, let's go to math, and let's set it R to 100, radius of 100. And let's also create a variable. Click on variable, set item. We're going to set a theta. Let's rename this variable to theta. Click OK, and that's going to be also under math, and we're going to call that, let's let theta start at 0. So now, instead of moving forward by 100, we're going to delete that, put that in the garbage can, and let's go to math and put in, variables, and let's choose variable R and move forward by R. Reset our program, run it. There you go. That's part 1 so far. We are ready to go on to part 2. We need to loop around the circle a certain number of degrees. So we are going to need a loop. Let's go ahead and repeat a certain number of times. And let's repeat, why don't we repeat for right now 36 times. And then we'll increment theta by 10 each time, 10 degrees, and we'll get 360 degrees around the circle. So let's drag this apart here. What do we need to do in our loop here? Well, R is set to 100. Turn right, move for, what we're going to do is we're going to take this move forward by R, and we're actually going to put that in our loop. We're going to move forward by R. We need to move backward by R. We'll throw out the 10. We'll go to our variables R, put that in, and then change the forward to backward. Well, let's just see what happens here. Oh, this is going to do this. Let's reset that. It's going to do that 36 times. What we need to do is we actually need to, in our variables, set theta. Let's put that in there. Theta needs to increment by 10. Means it needs to increase its own value by 10. So the first time through the loop it'll be 0. The next time it will be 10. The next time 20. And that we're going to get into the math section here and take this plus operator so that we can take theta to be whatever variables theta. So theta is going to become whatever theta was before plus math 10. And we'll take this 0 in and we'll just type the number in there, 10. Remember, if we're going too fast, always just rewind and take a peek again. So we've done that here, and then we need to make sure we take our turtle, and don't forget to turn. We are not turning right now. Polar angles, positive polar angles, we always turn left. And we're going to turn left by 10 degrees. And lo and behold, let's run our program now. Oh, look at that. I'm going to move the slider here to go faster. We just polar graphed a circle. if you were going to graph r equals 10, sorry, in this case r equals 100, this would be the graph you would get. Now, I know what you're saying. It doesn't look like a polar graph where these are plotted points. You usually don't draw these lines from the origin to the point. So here's what we're going to do to fix that. Are you ready? Watch this. When we move forward by r, here's what we're going to do. Let's go to our turtle. Let's take the pen and bring it up so that the turtle can actually come out to our point, moving forward by r. Let's put the turtle here. Let's put a pen down in between here. So pen down. And let's, after we do the pen down, let's do a little mark here. We're going to put in a move forward. Why don't we move forward by 2? And in the turtle, take another move forward and change it to move backward by 2. That's going to put a little mark. Okay? And then when we move backward by r to get back to the origin, make sure to take our pen and put it up. Did that go in there? There. Now let's see what we have so far. We put the pen, take the pen up, go forward by r, we'll move out, put the pen down, put a little mark, and go back. Let's slow it down and run it, see if it's working. Turtle goes out, makes a mark, goes back, goes out, makes a mark. This is true polar graphing. And you did the script. Look what you did. This is r equal to 100. I'm going to pause for a moment and we'll do part 3. Great. Let's continue. Watch what we have now. We were able to do the circle here. Now 36 times, if you want a greater resolution of your picture, instead of going 36 times, how about we go 180 times, and we'll turn by 2 degrees each time. So change the repeat loop to go 180 degrees, and instead of increasing theta by 10, increase it by 2, and turn left by 2. Now, let's just run that really quickly. Oh, and this is some great resolution here. Great resolution of our circle. Really nice. What we have next is, you're probably noticing we haven't used the theta yet because we are still turning left by 2. Now we are going to use the theta. Are you ready? Here's what's going to happen. Instead of moving forward, right here, moving forward by r, we're going to let r change. So we're going to put in our variables and we're going to set r to be a certain number. What we're going to choose is, we are going to let r be some equation like a lemnicon or a cardioid, and what's going to happen is we're going to need to get some mathematical operators and use the sine and cosine function. So in our math, we're going to get one of these plus operators. Okay, and let's go ahead and try and add the number math 50. That's half of 100. And in the other expression over here, we're going to put in, let's say, 100 times sine theta. So let's put in this expression here, 100. So that's going to come into math. We're going to take this operator out here, get into a times. We'll need another math 100 variable. Let's put that in. And the 100, because that's going to give us our 100 pixels times math. This is where we look right there, sine. We're going to put that in. And what are we taking the sine of? Of course, variable theta. And look at what we've got. And then take this big thing, drag it in there. And we're going to set r to be right there. R is going to be 50 plus whatever 100 times sine theta is. Let's put that right in here at the beginning and watch the magic. Boom. Make that faster. Okay. And there's the lemnicon. This is awesome. And then this turtle here, I'm going to hide the turtle at the end. Watch this. Turtle, hide turtle. I'm going to put that right at the end. And lo and behold, you have a polar graphing item here. There's going to be a bunch of things that you can do with this equation. We're going to look up a whole bunch of different types of cardioids, lemniscapes, roses, whereas if this were 50 plus, if this were a bigger number like 75, how does that change things? A whole bunch of things we're going to be able to do. Okay, and basically from here, all you're going to be doing is modifying what's in this equation here, and you have basically created your own polar grapher. All right, awesome job, awesome job.